You are an executive at Hoover, one of the world's most famous vacuum cleaner companies. A rival has moved in on your market with a new product that everybody wants. Your mission, should you choose to accept it, is to come up with a new product, design it and test it, launch it and bring it to market. This process normally takes 3 years. You've got just 12 months. You have 10 seconds to decide. You either accept the mission or stop the tape. You have accepted the mission. Your first task is to come up with a concept for your new vacuum cleaner.
In industry, any new product means massive investment. So before embarking on the production of a new vacuum cleaner, Hoover's product development team conducts market research to establish the needs of the market and to find out what the customers want.
There are two types of research. There's qualitative research and quantitative research. The qualitative research that we conducted is normally in the form of group discussions, which we conducted. And effectively what a group discussion is you've got 8 to about 10 people within a room, and you ask pertinent questions and frameworks as to how they feel about their vacuum cleaner or any other product for that matter. It could be baked beans, it could be cornflakes, whatever.
Talking to customers isn't the only way of finding out about new trends in the marketplace. In a competitive world, market researchers have to be aware of what their rivals are doing.
Literally, we noticed that there was a lot more bagless sales taking place through a fairly innovative product from Dyson. Hoover obviously had got very strong credentials in floor care, but we recognised that this was going to become much more of a threat. What we didn't want to do was just simply copy the Dyson product in terms of the configuration, or indeed offer an inferior product at lower prices. We therefore had to do some development work to create a point of difference.
To stand out in the marketplace, any new product has to have what's called a point of difference. This means that one of its features has to be better than the other products already available on the market. The point of difference could be the price, quality, or in Hoover's case, the introduction of new technology. In the oil and gas industry, cyclonic techniques are widely used to separate the mixture of water, oil, grit and gas that's pumped up from under the ground. When a mixture of a gas, liquids and/or solids is spun at high speed, centrifugal force throws the mixture outwards. The heavier parts of the mixture have a greater momentum and are flung out towards the edges. The lighter material stays nearer the centre. Hoover's product development team realised that by adapting and miniaturising an oil and gas separator called the WellSap, they could come up with a bagless vacuum cleaner that met the needs of their market research, but more importantly, was different from the existing bagless vacuum cleaners on the market. The triple vortex technology at the heart of the concept works in much the same way as a cyclonic oil and gas separator. Suction from the motor pulls up air and dust from the carpet. This mixture is then fed into the first separator at an angle which causes it to spin. Centrifugal force throws the heavier particles to the sides and they fall down into the dust container. The air still contains finer particles which pass through the screen onto stage 2. Here the air is spun again. The clean air at the centre of the centrifuge is removed and the remaining air and fine particle mixture passes on to stage 3. Here the speed of the spinning increases dramatically. Even very fine particles are thrown out to the sides of the separator and these fall down into the centre of the dust container. The air mixture could still contain very fine dust particles, so it passes back up into the stage 2 separator. Any particles that remain will recirculate until they're finally removed. By combining this technology with their own design expertise and the requirements of the market research, the development team come up with a finalised concept.
Once we've got that concept finalisation at that stage and the brief finalised, we know the specification of the product, the performance requirements, and we've got an agreed time scale. and we've also got an agreed indication of cost and price. And then we immediately go into design, and we spend approximately 12 weeks designing the product, drawing the product, and we use 3D CAD.
Computer-aided design, or CAD, allows designers to produce a working virtual model on their computer screens. From their models, they can see how different parts will fit together, what the cleaner will look like, and they can even assess how well it will work. Meanwhile, the market researchers continue to get feedback from focus groups. It's easier to make changes now than later on in the process.
By and large, when we received the product from its design stage, there were certain elements about the product that were fixed. Other parts weren't as fixed. So we were able to sort of move things along and modify certain elements of the design in order to take advantage of the research that was telling us how we should bring the product together and how it should look.
You have successfully come up with the concept and designed the product in 20 weeks. You have 32 weeks left, but you still have to make and test the prototypes, get the factory ready and launch your product. Fortunately, help is at hand.
Only a few years ago, this workshop would have looked completely different. Prototypes would have been made by hand and the whole process would have taken months. Today, it's a different story and a whole lot quicker. The CAD data from the virtual model is fed directly into a highly specialised model making machine, which uses a process called stereolithography.
What we're looking at here is the PC that's used to drive the machine tool. And you can see that there's an area of shading which is actually a very thin cross-section of the CAD model. The whole process works by creating thousands and thousands of 2D strata which are literally built up on top of each other to create a very complex 3D model. The models themselves are built on model build tables, and what we have is a metal plate with a series of holes in which allow the model to adhere to the table as it's built. The table itself is positioned just under the surface of photopolymer resin. In this particular case it's an epoxy-based resin. The resin changes from a liquid to a solid in the presence of light. A particular frequency of UV light allows that process to happen. The table itself drops approximately 0.1 of a millimetre, although the strata thicknesses can be pre-programmed. An arm traverses the table to lay down a thin layer of resin. There's a slight settlement process, and then the liquid is changed from a liquid to a solid in the presence of light, delivered through a laser. So what we can actually do is create a very, very fine cross-section and quite literally colouring using the laser as well. Once one layer has been built, the table drops, the arm traverses again, second layer on top of the first, laser comes along, cures the second layer on top of the first, and away we go again. And the process is repeating hundreds if not thousands of times to create the complex 3D models which become our prototypes.
The finished models are then put in an ultraviolet oven for final hardening. Using this technology, it's possible to produce models of almost any shape and size, from computer chips to these interlocking cubes. These would be impossible to make by any other method. And this technology isn't only useful in industry.
What we're able to do with this technique is take patient's data from a CAT scan or MRI, convert what is essentially 2D strata again into 3D facsimile, separate hard and soft tissue, and help the surgeon in preoperative planning. So in this particular instance, remove any of the debris, create the plate prior to first operation, actually trial the operation offline from the patient, and then finally go in for a single operation to fit the plate. It's still, in industrial terms, experimental, but to give you some idea of the success rate, that you would normally have a very high percentage, 70, 80, 90% expected failure rate, and failure rate in medical is death. Whereas one surgeon who's using this at the moment, over the last 4 years, has not had a failure rate.
The resin models tell designers what the product will look like and how the different parts will fit together. But in the case of the Hoover Vortex, They needed to produce working prototypes to test the performance and durability. Using the resin model, they make silicon rubber moulds to vacuum cast 50 sample models. The two halves of the mould are taped together so nothing will leak out during the casting process. A special resin is mixed up and then placed in the top half of the vacuum casting machine. The taped mould is placed in the bottom compartment. This is linked to the resin in the top by means of a plastic tube. The machine is then sealed and turned on. The air is sucked out of the chamber containing the mould, creating a vacuum. The difference in pressure pulls the resin down the tube and forces it into the mould. If the resin was just poured into the mould, the result would be a model with numerous air bubbles and imperfections. But by using this method, the complex pieces can be cast with a very high success rate. The process only takes a few seconds. The mould is then placed in an oven for 45 minutes to harden the resin inside. The result is a perfect replica of the original model made on the stereolithography machine. The casting is then taken to the model finishers. These highly skilled people remove all the casting nodules and piece together the finished working model. The next stage is to test it.
Your mission so far is a success. You've come up with the concept, designed your vacuum, and now have some prototypes. But before you go into production, you need to be sure that your new product doesn't just look great, but will stand the test of time.
If a product is recalled due to a design fault, it will cost Hoover millions of pounds, and it's therefore vital to test every aspect of the new design before going into production.
The purpose is to test our designs and our materials to make sure that they can last the life that we would expect them to last, which is around 10 years in normal household usage. So what we are attempting to do in a very short space of time is to try and simulate what could happen in the most rigorous areas in a household, and which would occur over a period of 10 years. So they've got to be rigorous tests. Sometimes we test them beyond the necessary points, but then we always learn from that.
Different types of cleaner could have different weaknesses, so the tests are tailored to the particular product. Here, a cylinder vacuum cleaner is being dragged over different surfaces by the hose. This tests the strength of the hose and the wheels underneath. The Vortex has its own specially designed test.
This is what we call the serpentine test. As you can see, the product is going through a rigorous path. At the end of its cycle, it's hitting off an object, and as it returns, you can see it's hitting off another object. What we're trying to do here is simulate someone using this vacuum cleaner in the house for 10 years, bumping it off skirting boards, bumping it off door jambs. Very, very effective test. You'll notice also that we grip it by the handle. When we put the first one on, the handle's broke in a very short space of time. Other than that, it has proven to be okay. Everything else was as we expected it. But bear in mind that we used our experience in the design and we're anticipating problems.
The testers play an important part in the development of the prototype. All the information they discover is fed back to the designers so that they can continually modify and refine the product. When they discovered a weakness in the handle, it was redesigned and retested. Of course, it's not just the product that has to be tested. Any large assembly plant has to develop special tools and working practices to make a new product.
Now, at the same time as we're testing the prototypes, we're at that point then talking to the tool makers, because we need to talk to tool makers to make the plastic moulding tools. So we've kicked off the testing, we've kicked off the tool design, And the tool design on a reasonably major product will take anything up to about 20 weeks.
All the body panels are made in plastic forming machines, but each part requires its own specific metal mould, and these have to be specially made. Granules of resin are pumped into the machine and heated so they become a liquid. Huge pistons inject the liquid into the mould under pressure. It cools and hardens. The result is a perfectly formed plastic part. These moulding machines are extremely efficient, and working to capacity, a single machine can produce hundreds or even thousands of parts a day. In this factory, computer-controlled forklift trucks ferry the finished pieces to the stock area. This enables the process to continue 24 hours a day. But it's not just the machines that have to be updated to accommodate the new product line. Whilst the tools are still being refined, they begin training staff for the new assembly line.
What we do is we select a team initially of about 10 to 12 people, and we take them into the engineering department, and the engineer trains the personnel up. A week prior to the introduction of the product, the pre-production, we bring on board the personnel that will actually build the product, and we give them a full training in all aspects of them. We then decide in groups of about 5 people, and we select them into individual areas. They are into sort of teams of 5, which have got specialist knowledge in that 5 operations. We go into production, and we start off production at maybe a 50% increase in the first week to make sure the quality and the training is acceptable. But we stop the line each day. We ask the personnel on the line to decide and tell us if there are any problems in the job, anything they could help the engineers with in the developing of it. And from the second week on, we're going to full production.
So you've tooled up and trained your staff, you're ready to go into production, and you've still got 2 weeks to go. But haven't you forgotten something? You can have the best product in the world, but your launch will be a flop if no one knows about it.
The secret to a good campaign, well, if I revealed that, then I'd be out of a job. But generally, we're led by whatever the product can deliver. In this case, we were very lucky in that there was a very clearly identifiable USP, no filter replacements.
The first step in any marketing campaign is to identify your USP, or unique selling point. This is what makes your product stand out from the others on the market. The next stage is to decide the other key points you want to communicate to potential customers.
Basically, we had to identify how much did we talk about the science element of the product, how much did we talk about the bagless element of it, how much did we talk about no filtration, no filter replacement, and also how much did we talk about carpet care. Then there's a whole host of features that you can talk about in terms of the bin, the cord rewind, etc., etc. Now the critical thing that we have found, and I think we've got it right this time, is to concentrate the mind and the communication on a few items only.
The marketing team identified 3 key elements, and these appear on every piece of supporting material.
We have a miniature pack here, as you can see. We've clearly put the 1, 2, 3 communication on the pack, talking about the Vortex system itself, the no bag, no filter replacement, and no problems, and then carpet care. We also used a piece of imagery which was to get a scientific approach to feel to the actual communication, where we used an X-ray shot of the product so that we gave a technical buzz to the actual communication. And then we also had the support of the secondary points listed quite clearly in terms of icons. One of the things that we are guilty of in marketing at times is trying to speak about all these messages here all at once, and then the communication breaks down. So as far as we're concerned, the primary part is 1, 2, 3, and the clear messages that are communicated there.
A bagless vacuum cleaner that recirculates air continuously to ensure that only the cleanest air is expelled, and is so efficient you never need to replace the filter.
A successful campaign means getting these messages across to as many potential customers as possible. The easiest way to raise awareness is through television advertising, but this is extremely expensive, and there are lots of other ways to let people know about your product.
We have to approach our literature in a way that communicates clearly the message in a number of angles. So for example up here, as you can see up here, in the actual store itself the product would be shown with the box either side and a header board saying no bag, no filter replacement, no problems. We also have mats, for example, with no bag, no filter replacement, no problems, using the motif which you can see here on the triple vortex system. In terms of our actual literature which are given to consumers, we're using the X-ray field to get the scientific approach, and then we communicate clearly about the oil industry, which was number one if you recall, the vortex system itself, and then as you can see, like a ready reckoner in effect, our message is absolutely clear: 1, 2, 3, and the supportive icons that I discussed earlier. But we also put this on literature which we gave to the trade, but we also put it onto the internet as well. So we had the facility of actually pressing a button or putting the cursor on a button, which would then take you through different stages. So we actually went through the triple vortex system itself, and we had a little fun thing where you can actually go and look at dust mites in terms of what's in the carpet itself.
Your mission is nearly complete. You've designed and tested the product, you've tooled up and trained your staff, and your marketing team is ready to launch its campaign. Production can begin.
Vacuum cleaners may look simple, but they have hundreds of different parts. Some of these are made in the factory itself. Others, like these motors, are bought in from outside suppliers. The different components are put together on sub-assembly lines. Here, the main vortex unit is being welded by a sonic welding machine. This uses extremely high-pitched sound waves to melt the components together. Each unit is then tested to ensure that the seal is completely airtight. The vortex units then pass on to the main production line. The speed of the line can be altered to vary the number of cleaners being produced. Each worker has the same amount of time to perform their particular task. This will have been carefully worked out during the training and testing period.
The pace line which you see here is designed to run the schedules between 2,000 and 5,000 per week on a day shift basis. So within an 8-hour day we can produce 5,000 cleaners over the course of the week, working 5 days. If the schedule required is 5,000, the work study engineers prior to the production come in will look at each content of each job and work out how long it takes to put in a screw, to lift a cover, and to work out a time. That time is then put into the person's job. The actual overall time of the job is determined by the amount of cleaners you require each week. Currently the line is running at around 2,500 per week, which is around a cycle time of 48 seconds. So each operator is around 48 seconds content of work, and that's right through the line.
Mass production techniques are extremely efficient, but performing the same task over and over again can cause repetitive strain injury. To minimise the risks, tools like these screwdrivers are motorised. Most factories have also introduced special working practices.
In the morning we have a break at 9:30, a break at 11 for pace line breaks to give them relief, to give them to go to the bath, etc. During that period of time they tend to rotate through different jobs, so they're using different muscles throughout the day, and also gives us the flexibility of people with additional knowledge of that job in case someone is absent or we have a new person on the job.
Quality control is a vital part of any industry. If a vacuum cleaner is faulty when it leaves the factory, it will not only cost the company money to replace it, but will also damage their reputation. So before they're packed up, each finished model goes through rigorous testing. Everything from the cable to the suction and the speed of the motor is carefully checked. Finally, each vacuum is given a visual inspection to check there's no defects in the case or the paintwork. One year after it all began, the first vortex rolls off the line.
Congratulations, your mission is complete. But before you go off on that break, you better have a word with the boss.
As soon as we put a new product in the market, we're looking at its replacement. I mean, we have a rolling 3-year program. I mean, sometimes we've already mapped out a successor to a new product before we've introduced it.